Science Grade 5. Quarter 3 Module 5. Week 5, Lesson 5. Components of an electric circuit. After going through this module, you are expected to A. Identify the basic parts and functions of an electric circuit. B. Describe closed and open circuit. And C. Construct an electric circuit. Direction. Write true if the statement is correct or false if it is not. Write your answers on a separate sheet of paper. 1. The chemical reaction in a dry cell involves the flow of electrons. 2. Always plug the appliances even when not in use. 3. For an electricity to become useful, it must circulate continuously and follow a loop called electric circuit. 4. Unplug and use proper tools with plastic or wooden handles when repairing electrical equipment or device. 5. A current will not flow in an open circuit. 6. It is safe to touch an open wire with your bare hands. 7. When the switch is on, the circuit is closed. Electricity flows and the bulb lights up. 8. A switch controls the flow of electricity from the source. 9. Avoid many appliances plugged in one socket for it might cause fire. 10. Never go near wires with cuts or those that fell to the ground because these could electrocute you. Direction. Arrange the following letters to form a word. Write your answers on a separate sheet of paper. 1. It is a device that uses electricity from the source. 2. It provides electricity. 3. It controls the flow of electricity from the source. 4. It is where electricity travels. 5. It provides symbols that show how the electric circuit is constructed. 6. It is produced when electrons are transferred from one object to another due to friction. 7. It is the rate of flow of electrons. 8. It is a positively charged particle. 9. It is a negatively charged particle. 10. It is a neutral charged particle. Lesson 5. Components of an electric circuit. In this module, you will be able to determine the effects of changing the number or type of components in a circuit. Light is a vital element in our daily lives. It helps us throughout the day. It wakes us in the morning and lulls us to sleep at night. Draw a bulb with rays and write ways on how light affects your daily living in the community. Write your answers on a separate sheet of paper. Discussion of activity. Look at your surroundings. Everything that you see that has to be plugged contains electric circuit. Anything that has a battery also contains electric circuit. Our daily living is surrounded by them, from light bulbs to computers, from cell phones to refrigerators. Can you live without electricity? In the past century, we have replaced manual labor with machines which are powered by electricity, developed our ways of communicating, and improved our ways of living. Today, we will learn more about electricity. If all train tracks are properly connected, the train can move. Circuits are like train tracks. For an electricity to become useful, it must circulate continuously and follow a loop called electric circuit. These materials are needed to be attached properly to one another in a closed circuit and an open circuit. If one of the wires is detached from the battery or if the bulb is not fully screwed into the socket, then the electricity will not flow, and the bulb will not light. There are 4 components to make the bulb light up. 1. The light bulb is the load, a device that uses electricity. 2. The wires in the circuit provide a complete path for the current to flow. 3. The battery, dry cell, supplies the current electricity. The chemical reaction in the battery involves the flow of electrons. 4. The switch is conveniently designed to open or close the circuit. Source, dry cells. Switch, wires. Loud, light bulb. Closed circuit is one that is complete, with good continuity throughout. It has a complete electrical connection around which current flows or circulates. A closed circuit is a series of electrical wires connected to each other so that the current travels from one end of the circle to the other. Closed circuit. Source, dry cell. Wires. Loud, light bulb. Here is a diagram of a closed electric circuit. Know that the lines in right angles represent wires or connections, and this represents the dry cell, battery, and is the closed switch. Open circuit. Source, dry cell. Wires. Loud, light bulb. On the other hand, an open circuit is where the continuity has been broken by an interruption in the path for an electrical current to flow. The interruption is due to an open switch or frayed wire. In this diagram, the open switch is represented by this. Since the switch does not complete the circuit, electricity cannot flow from the source to the load. Guided Activity 1. Direction. Match the definition in column A with the concepts, symbols in column B by choosing the letter of the correct answer. Write your answers on a separate sheet of paper. Column A. 1. The chemical reaction in a battery involves the flow of electrons. 2. It is a device that opens or closes the circuit under controlled condition. 3. It is a connection that provides a complete path for the current to flow. 4. It is a type of circuit where electrical connection circulates completely. 5. It is a continuous path where electrons move. 6. It is a type of circuit where the continuity has been broken by an interruption. 7. It symbolizes a closed circuit in a diagram. 8. This represents the connections used in a diagram. 9. It is a symbol in the diagram that means the circuit is open. 10. This represents the source of electricity in a diagram. Column B. 8 wire. B open circuit. C source. D electric circuit. E closed circuit. F switch. G. H. I. J. Guided Activity 2. Direction. Gather the following materials and follow the procedures below. Ask an adult for supervision, especially when handling sharp objects. Safety tips. Observe safety procedures throughout the activity. Handle the light bulbs gently, as broken bulbs can produce serious cuts. Do the activity with the supervision of your parent or guardian. Materials needed: cardboard square or 1/8 illustration board, D-size battery, electric wires, electrical tape, pair of scissors, 2 pieces paper fastener, pliers or long nose pliers, flashlight bulb, 1 safety pin, paper clip, plunger. Procedures. 1. Get a 1/8 size illustration board or cardboard. 2. Punch 2 holes in it and place 2 paper fasteners. 3. With a pair of scissors/pliers, carefully remove the ends of the wire. 4. Cut 3 pieces of electric wire, each measuring 10 centimeters long. 5. Assemble the other materials by referring to the illustrations below. 6. Clip the safety pin to the wires. Observe what happens. Guide questions. Write your answers on a separate sheet of paper. 1. Which part of the circuit provides electricity? 2. Which part of the circuit receives electricity? 3. Which part of the circuit transfers the electricity from one component to another? 4. Which part of the circuit completes the flow of electricity? 5. What happened to the bulb when the fastener touched the wires? Guided Activity 3. Direction. Answer the following questions. Write your answers on a separate sheet of paper. 1. Which parts of the electric circuit carry electricity from one component to another? 2. Which part of the electric circuit does the electricity come from? 3. When do you say the circuit is closed? 4. Which part of the electric circuit receives the electricity? 5. When do you say the circuit is open? Guided Activity 4. Direction. Create a poster about safety rules and precautions in using electricity. Materials needed: crayon, ruler, pencil, short bond paper. Poster rubrics. Direction. Fill in the blanks with the missing words. Choose your answer from the box. Write your answers on a separate sheet of paper. Light, switch, open circuit, wires, source, electrical connection. The 1 blank is where the continuity has been broken by an interruption in the path for an electrical current to flow. Closed circuit is one that is complete, with good continuity throughout. It has a complete 2 blank around which current flows or circulates. A closed circuit is a series of electrical 3 blank connected to each other so that the current travels from one end of the circle to the other. A device designed to open or close a circuit under controlled condition is called 4 blank. If one of the wires is detached from the battery or if the bulb is not fully screwed into the socket, then the electricity will not flow, and the bulb will still not 5 blank. Direction. Gather the following materials listed below. Ask one adult for help in carrying on with this activity. Read and follow the procedures. Then answer the questions that follow. Write your answers on a separate sheet of paper. How does changing the type or number of components in a circuit affect the brightness of the bulb? Materials needed: 3 pieces, D-size batteries, battery holder, 220 centimeters long wire, 3 pieces, flashlight bulbs, pair of pliers, switch, alligator clips, electric tape. Procedure. 1. Use the simple circuit in Activity 1 you constructed. Write label circuit X. Observe the brightness of the bulb. Use 1 battery, 1 bulb, the switch, and the wire. 2. Construct another circuit and label it circuit E. Observe what happens. Use the same materials but put only 1 bulb for 2 batteries. 3. Put 3 batteries in a battery holder. Again, connected to 1 bulb. Write label circuit Z. Observe the brightness of the bulb with 3 batteries. 4. Compare the brightness of the bulb in circuit X, circuit Y, and circuit Z. 5. Use circuit X again. Use 1 battery and 1 bulb. 6. Use circuit Z and construct another circuit. Use one battery with two bulbs in a circuit. Observe the brightness of the bulbs. 7. Compare the brightness of the two bulbs with the brightness of the three bulbs using one battery. Reflection, observations. Write your observation on a separate sheet of paper. 1. Copy and complete the table below. 2. What happened to the brightness as more bulbs were added to the circuit? 3. When more batteries were added to the circuit, what happened to the bulb's brightness? 4. What are the effects of changing the number or type of components in a circuit? 5. How can you make bulbs brighter? 6. Write your conclusion to the problem. Direction. Read the questions carefully. Write your answers on a separate sheet of paper. 1. What will happen if the battery is in place, the switch is on, but the bulb is not in place? A. It will not produce light. B. The bulb will shine brightly. C. It will make the bulb dimmer. D. It will turn the light on and off. 2. What is most likely to happen if the switch is on and the battery is removed from the circuit? A. The bulb will shine brightly. B. The electricity will flow properly. C. Electric current will continuously flow. D. The electricity will not flow, and the bulb will not light. 3. Which component is missing in this setup? A. Load. B. Source. C. Switch. D. Wire. 4. What will happen if all the components of a circuit are in place? A. There will be a short circuit. B. The current will stop flowing. C. The electricity will not flow, and the bulb will not light. D. The electricity will flow properly to the components, and the bulb will light. 5. What will happen when more batteries are added to the circuit? A. The bulb will light. B. The bulb will not light. C. The bulb will light brighter. D. The bulb will become dimmer. 6. What type of circuit is shown in the picture? A. Closed circuit. B. Electric circuit. C. Open circuit. D. Short circuit. 7. What do you call the continuous path over which electrons move? A. Brightness. B. Dimmer. C. Electric circuit. D. Wire. 8. Which of the following best describes an open circuit? A. It is a path of electricity. B. It is a broken path of electricity. C. It is the continuous flow of electricity. D. It is a broken path of an electric circuit due to the disconnected switch. 9. Which component is missing in this setup? A. Load. B. Source. C. Switch. D. Wires. 10. What will happen to the electric circuit if wires are not connected to the components? A. The electric circuit is broken. B. The components will work properly. C. There will be no path for the electricity to flow. D. All of the above.